All right, the next section here is displaying quantitative data with stem plots, which you may have called stem and leaf plots in the past, but we're going to call them stem plots. We're going to take a look at those, and it's really not creating the stem plot, it's more analyzing the data. So um, let's go ahead and take a look at the first objective, which is to interpret stem plots. And some vocabulary, again, making sure that when we look at this, the stems consist of all but the final digit. So when we look at the stem plot, we see that over here on the left is what is called the stem, and the leaf is just the final digit. So this would be the tens place, and that would be a 5 as 15. So stems are ordered from least to greatest in the column, and leaves are arranged in increasing order from the stem. So again, it's always going to go smallest to largest down, and then smallest to largest to the right. The one thing that you have to make sure is you have to have a key for every one of these. So in this specific example, you put the 2 and the 8, and that tells you that means that it contains 28 milligrams of caffeine per 8-ounce serving. Okay. So again, sometimes just a little note here. You notice how it's a repeated 2. That's called splitting the stem. So instead of having a long list of numbers to the right, we can split that. And usually the numbers are split right in half from 0 to 4 and then 5 to 9. So instead of having one long line in the 20s that goes all the way out here, we split it. And you can see it just makes for a little bit easier to read this stem plot. Okay, there's no magic number of stems. You doesn't automatically have to have 5, doesn't have to have 10, but 5 is a good minimum number. If you're making a stem plot that only has 1 or 2 numbers over here on the left, then usually you don't get a good picture of the data, and that's when we would split it if there's only 2 sets or 3 sets of numbers. So and again, in splitting the stems, we're going to assign equal numbers to the leaves. So like we did here. Okay, so again, this would be 1, and then this would be the 20s to 24. This would be 25 to 29. This would be 30 to 34. This would be 35 to 39, so on and so forth. So typically we use 0 to 4, 5 to 9 to make that data look nice. And you could split it 3 ways or 4 ways, depending on how much you needed to split this. But again, we're more interested in interpreting the data here. So we're going to take a look at an example. Okay. And it's who has the most votes. And it's to become president of the United States, a candidate does not have to receive a majority of the popular votes, which I believe has happened. Didn't happen this year, but happened the last couple of elections. I know Hillary Clinton had more votes than Donald Trump, but Donald Trump won the electoral votes. Therefore, he was our president. And I believe it happened before that as well. So the candidate does, however, have to win the majority of 538 electoral votes that are cast in the Electoral College. The stem plot here shows the number of votes, and we're just going to call that EV in 2016 for each of the 50 states and District Columbia. So we should have a total of 51 votes, right? We should have a total of 51 votes because there's 50 states and the District of Columbia. So 50 plus 1 is 51. So it says, what percentage of states get 10 or more electoral votes? So we're looking at this, and as you can see, the stem here starts at 0. So this would be 0 to 4. This would be 0 through 9, or 5 through 9, really. Then we start here at 10 through 14, and 15 through 19. So if we go through this, it says what percentage of states get 10 or more electoral votes, 10 or more. So that would be starting in this column here. These are all under. So we would say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 here. 1, 2, 3, 4 here. 2 here, 2 here, 1 here, and 1 here. So if we add all those up, we get 11 plus 4 is 15, 17, 19, 20, 21. So we'd have a total of 21 out of 51. Okay, so we would take 21 over 51 and then multiply that by 100. So if we go to our calculator and we enter in 21 divided by 51 and we multiply that by 100, it will give us our percent. Make sure that we are multiplying correct, times 100. And we get 41 0.17%, and we could round that to 41.2%. So this equals 41.2%. We rounded up because it was 1.7. The 7 turns that 1 into a 2. Okay, so now describe the shape of the distribution. And again, there's 4 things that we are looking at here. So we're looking at the shape. Okay, and again, when we look at this, and this is what's difficult, if we were to flip this horizontally, it would start at 0 and it would end here at 5, right? And we would see that there would be the 1 and the 2 and the 3, and we would have these going way up high here, as we can see this. So you can see that this is clearly skewed to the right as all this data continues to go further and further to the right. If we flip that, it's definitely skewed to the right. Okay, because the data again would continue to go further and further and further that way. We want to look at the peak. Okay, we can see that the peak is right here. Okay, and that would be between 5 and 9 electoral votes. So the peak is this one right in here. Clusters. It looks like the clusters are really from here down to there, which starts from 3 and goes to 29, right? Goes down to 29. So the clusters would be 3 to 29 electoral votes. And then the last one here, are there any gaps? Okay. And we can see that there's a gap from 29 to 38. So 29 to 38 electoral votes. And then there's another gap from 38 to 55. I don't need to write gaps again. But from 38 to 55. So again, the main 4 things we want to look at when we're describing the shape of distribution is the shape, the peak, so we want to know whether it's skewed right, left, or if it's symmetric, the clusters, and the gaps. Okay, then which 2 values appear to be the outliers, and that should be pretty evident. 38 and 55 would be my 2. Clearly 55 electoral votes, and 38 I would also add in there as the outliers. So we're going to have a few problems where you're asked to describe this in this section. Again, we're not so much concerned about creating a stem plot, but we're going to have to be able to analyze the data through this. So you got a few questions to work on with this.